Alright, let's talk about the unit path. So you're given an embedded matrix, and then you are located on the top left corner, and then you want to go on the bottom right corner. And then the robot can only move either down or right. So you want to return a possible unit path. So this is the unit path, right? And then you can only go from down or right? So there are two solutions. One is DP, the other one is DFS. So let's talk about the DP first. So the DP will be more general solution for this one. And then just look at this. If you keep going right, you are not allowed to roll back, right? So this is one path. And if you keep going down, this is one path, right? And then for list cells, for list cells, you can actually goes from this way or this way, right? So there are two possible way, right? So I'm going to say two. All right. So once again, I'm going to just demo one more cell, but you will definitely know what happened. So for these cells, you are allowed to go from here to here, right? And then definitely from here to here, right? And then definitely from here to here, right? Unique path, right? So again, you probably will notice you are going to sum your top and left cells if the current x or y is not equal to 0, right? If this is equal, if x or y is actually equal to 0, you are actually make a default value equal to 1, right? And then whenever this is not a edges, right? Let's call edge. If the cells is not on the edge and you want to add the top and left, which is going to represent 4 here, 5 here, 6 here, 7 here, and this is going to be what, 3, and this is going to be 6, this is going to be 10, this is going to be 15, this is going to be 21, and when you finish, 21 plus 7 is going to be 28. So this is the solution. So let me start coding, and then you definitely know like this is not a hard question, right? So I have 2D array, new int. I'm assign m and n, and then I need to what make the default value on the edges, right? So I'm going to say dp. So again, this is for the row, right? So it's going to be I 0 equal to 1, right? And then once again for the column, let me just use j dp. This is going to be what, 0 j equal to 1, right? All right. So from what, from I equal to 1, I less than n, I plus plus. For I equal to j equal to 1, j less than n, j plus plus. And then if you want to return, the last cell, n minus 1, n minus 1. Alright, you want to minus 1 because the index, right? You are only assign n, and then the index started from 0 to n minus 1, so you want to just return the last one, right? And then this will be easy, so just dpij equal to what? Top or left, right? Top plus left, right? So this is going to be what? Top is going to be dp ij minus 1. No, sorry, this is I minus 1. This is for the top. And then this is going to be what? dp ij minus 1. This is going to be for the left. And then here we go. So let me run the test case. Alright, submit. Alright, accept, right? So let's just go for the debug mode. So I'm going to break the point right here and then get out, start debugging. So I want to show like the default value for the DP. So this is for DP. When you initialize the DP, equal to 1, right? And I'm going to leave the breakpoint, and then I'm going to just keep going, and then you'll just keep seeing the updating. I'm not going to talk, but this is super straightforward. Alright, so finish, right? And then this will be the solution. So how do I cancel? Like this. And then, oh, sorry. So if you want to return, just return this one. And I didn't actually, you know, break the point right here. But let me do this. Should be okay. Right, 28. Alright. So let me access. So this is a solution for DP. So let's talk about the recursion. So recursion is pretty straightforward, right? So I'm going to just starting from the bottom right, and then I'm going to just keep adding. Sorry, yes, I'm going to keep adding the top, and then the left, and then when this is not edges, I'm going to keep adding for the top and left, something like this, right? And then when this is the edge, right? When this is going to be the edge of the metric, I'm going to just return 1, right? And then this is it, right? And then I will return what? Return the current, the starting position. I mean reversely. So this should be straightforward. So I'm going to initialize the metric. So you can name anything you want. So it's going to be m and n. And then I need to return the DFS mat, and then it's going to be n-1, and then n-1, and then probably void. Sorry, probably in DFS in mat and metric in x in y. So I'm starting from the last cells, so which is a finish point, bottom right? So if there's a value assigned which is what, greater than 0, you just return, and everything else should be straightforward. So it's going to be mat x y equal to what, you call this function, you call mat, you call x-1, you call y, plus DFS mat x y-1, and return max xy. So I almost finished, but there's a base case, right? Because if you keep -1, right, and then I mean -1 for x, -1 for y, and there's going to be the edge, right? So it's going to be what, if x is actually equal to 0 or y is actually equal to 0, right? You want to return 1. And then just in case you are afraid of outer bound, right? Less than 0, y less than 0, you want to return 0. So this is a memorization recursion. So let me run it. Oh, mat. And yes, submit. Alright, so it's pretty easy. So if you want to just get rid of this, I think it's fine, but let me see. Yes, should be fine. Yes. So this is a base case of a base case for this one, right? And then the time and space complexity for the current solution is going to be DFS. It's going to be what? I'm going to copy my solution. The time and space is going to be all of m, and then space is going to be mn, because you are what? Generate a metric. And then back to the DP. And this is going to be exactly the same thing. Why? Traversing every single cell, right? You are traversing every single cell, you are adding every single cell, you are actually creating a 2D array. So time and space are the same, m and n. And this is the solution. So if you have any question, leave a comment below, subscribe if you want it, and I'll see you next time. Bye.